Number 1. Negative 0.7 squared. Notice that the negative sign is outside the grouping symbol. Therefore, the negative sign is not part of the base. So when you solve this problem, simply copy the negative sign first. And then 0.7 is inside the grouping symbol. Therefore, 0.7 is the base. By definition of exponents, we multiply the base twice. And we simplify this by the order of operations, and we obtain negative 0.49. Number 3. Negative 4 cubed. Notice that this time the negative sign is inside the grouping symbol. Therefore, the negative sign is part of the base. We use the definition of exponents, rewrite the base 3 times. Simplify by order of operations, we obtain negative 64. Number 5. X raised to the 0th power. By definition of exponents, if you raise any non-zero real number to the 0th power, you obtain 1. Here, our base is x, so we assume that x is non-zero. If that's the case, then x raised to the 0 will be 1. Number 7. 7 to the 4th times 7 to the 6th. This one you have to use the product rule. So if you remember, the product rule applies to exponents that have the same base. Let's assume we have these two exponents, x to the 8th times x to the bth. They have the same base, x. You simply add their exponents and keep the base. Therefore, for the first one, 7 to the 4th times 7 to the 6th, we simply add the exponents and keep the base. And that will give you 7 to the 10th. On your exam, if you have a problem like this and you have to simplify exponents, you don't have to write down the actual value. This is sufficient. Number 9. M to the 3rd times n to the 1st. This one, you might be attempting to apply the product rule and add the exponents, but what about the base? They don't have the same base. Therefore, this one is not possible. Or you could also say can be combined. Next page. Number 11. W to the 6th over W. This one you need to use the quotient rule. Quotient rule is talking about the division of two exponents that have the same base. In this case, we simply subtract the exponents. Therefore, for number 11, we subtract the exponents. You may notice that there is no exponent in the denominator, but there is an invisible 1. So if you put an invisible 1 there, we will subtract 6 by 1. And our answer will be W to the 5th. Number 13. B to the 4th over A squared. Again, you might be attempting to subtract the exponents, but pay attention to the bases. They don't have the same base. Therefore, this one is again not possible or cannot be simplified. Number 15. X squared times x to the 4th times x cubed. This one, we're going to use the product rule. Since they all have the same base, we simply add the exponents. 2 plus 4 is 6. 6 plus 3 is 9. So the answer is x to the 9th. Number 17, you have to use both rules. There are multiple ways to do this. If you want to do it step by step, I recommend that you simplify the denominator first. The denominator is b times b squared. So if you put an invisible 1 next to the b, you can apply the product rule. Simply add the exponents, that's b cubed. And then we apply the quotient rule again. Since they have the same base, we subtract the exponents. 6 minus 3, that is 3. Number 19. Study number 19, you may see expressions that have negative exponents. To deal with negative exponents, the best way to do it will be considering that you have a two-story apartment. Let's say this is the upstairs and this is the downstairs. The factors in the expression are the tenants of this two-story apartment. If the tenant is attached with a negative exponent, you're going to move it to a different floor. So let's use an example to demonstrate this idea. Number 19, a to the negative 1 times b squared. Right now, this looks like a one-story apartment. Let's make it a two-story apartment by putting the entire expression over 1. Now we have a two-story apartment, up and down. For the up part, we have two factors, a to the negative 1 and b squared. One of them has a negative exponent attached, which is the first one. Therefore, we're going to move that tenant downstairs. When you move it downstairs, you simply keep the base and change the exponent to the positive version. In this case, it's just going to be a to the first. The other tenant upstairs, it's b squared. It has a positive exponent, so you just leave it upstairs, b squared. The downstairs, there was no one there. We put a 1 there, but since we move a to the first downstairs, a to the first times 1 is still a to the first, so you don't need to put that 1 there anymore. And if we rewrite this expression, it could also be simplified to b squared over a, because for an exponent that raised to the first power, we don't need to write that out. Let's use another example to further illustrate this apartment idea. Number 21, 4 over a to the negative 4. This one is definitely a two-story apartment. So we're going to follow the same idea. Check out each tenant. Upstairs, we have a 4. What's the exponent of 4? Well, exponent of 4, it's simply just 1 because it's 4 raised to the first power, and that 1 is positive. Because it has a positive exponent attached to it, we're not going to move it. So we just keep it as 4. Now let's look at downstairs. Downstairs, you have a to the negative 4. Well, this one definitely has a negative exponent attached to it. That means we have to move it upstairs. So we keep the base, a, and then we rewrite the exponent from negative 4 to positive 4. So what happened to downstairs? We moved everyone downstairs upstairs. There's no one left out downstairs. Do you put a 0 there? No. If you put a 0 there, it's going to be undefined. So what you do is you put a 1 there. It's just like how we did it for number 19. We created a downstairs, but there's no one there. We put a 1. So it's the same idea. And then we can further simplify this. 4a to the 4th divided by 1, it's simply 4a to the 4th. Number 23, p to the negative 5 over q to the negative 5. Wow, both of these tenants, if you look at it, are negative exponents. They have negative exponents attached to it. Therefore, we're going to switch these tenants, put them to the different floors. Therefore, p to the negative 5, it's going to go downstairs and become p to the 5th. Q to the negative 5 is going to go upstairs and becomes q to the 5th. And that's it. Moving on to the last problem of this section. 25. A population of an ant colony in a section of a rainforest grew from a cubed to a to the 5th in a year. By what factor did the ant colony grow during that year? In this case, we simply do a quotient to find out the factor. The beginning is a to the 3rd and the end is a to the 5th. So you put a to the 5th on the top, a to the 3rd on the bottom. By applying the quotient rule, we simply subtract the exponents because they have the same base, and we obtain a squared. Or you could also write as 64. And that is the factor. Thanks for watching.